Hello everyone. Now we're gonna see how a deep learning neural network works. For that, we have taken a simple neural network as an example. Here it consists one input layer and one hidden layer and one output layer. And this each layer consists two neurons just for the sake of simplicity. And here the I1, I2 are the input neurons and H1, H2 from the hidden layer neurons, and O1, O2 are the output layer neurons. And besides, we have the biases. It's B1, B2. I mean, these biases are added between each two layers. So let's go and check how to pass the input and change the weights accordingly based on the output values. So for that we are going to pass an image to a deep learning neural network, and then the deep learning neural network has to identify what the image consists. Suppose if we are going to pass an image which contains dog image in it, then the neural network has to identify that there is a dog in the image. Then it has to classify the image as dog, and if suppose it contains cat in it, then it has to classify that image contains cat. So what we we're gonna do, we are gonna make this image to split into two neurons. Since we have got only two neurons in our network, so we are going to split this image as node 1 and node 2. So but this is not the actual case, because one image will be separated into multiple group of pixels, and then it will be passed into the input nodes. But here, for the sake of simplicity, we are just splitting it into two, and then the left side and right side, and then this two input values will be passed into the input layer. So let's suppose, just for the sake of simplicity, let's take that this n1 contains 0.5 and the n2 contains 0.2. okay, so we are going to pass this value in here. Okay, so this is 0.5 and this is 0.2, and then we would be filling the weights with some random values, since the network is not trained at the first place. So we would be initializing all this weights with some random values, and even the biases or used with some random values at the initial forward pass. And I will tell you why we need this bias, and this is very helpful. Biases are making the network more flexible. So okay, so what are these weights actually? These are the weights are actually the connection between the neurons. Okay, so here we have built the fully connected neural network. Each layer is connected fully with other layers, because why we call it as a fully connected layer, because each neuron is connected with the other layer's neuron, so that's why it's called as a fully connected layer. And we don't need the fully connected layer in the real-time development, but that could be determined based on your a problem and the development. So here the weight is W1, and I1 to H2 is W2, and here I2 to H1 is W3 and W4, and then the biases are just coming from the B neuron. And so all these values are calculated by in order to get the activation in H1, we have to multiply this input value with the W1 and input value of I2 with W3, and adding the bias, we will get the H1 here. And so here you can simply say by simplifying this equation, you can say just In into Wn, sum of In into W1 plus bias is equal to H1. If you just do the sigmoid is if you do the sigmoid of H1, then you will get the H out. H out is the activation function of this neuron, that H1 neuron. Here we are using sigmoid function as an activation function. The activation actually triggers this neuron to to activate the other layers neuron. So what is activation? Activation is nothing but like this neuron will get the value just above 0. If it is a 0, if you just do all the multiplication and get the value output as 0, then this neuron won't get activated. But if you get the value like 0.1 or just 0.5 or 0.8, then this neuron is activated highly. So this will affect the other layer neurons which it's connected to. So the activation is based on the value which we are getting in this input, and based on the weights we added here. So this is the sigmoid function to get the output of the hidden layer neuron. So here is the sigmoid function expression, which is 1 divided by 1 plus exponential of minus h. H is nothing but the h1. So this is the actual activation function. Here we are using the sigmoid activation function, but there are other activation function too, like ReLU and a few other activation function too, but sigmoid and ReLU are the most popular ones. So this is the way we are calculating the output of each neurons. The same way we are going to calculate the H2 as well, like I1 into W2 and I2 into W4 plus bias will give you the H2 value, and then if you sigmoid it, then it will give the activation value of the H2. So the same way we are going to calculate the values of other layer as well, even for the output layer. So we are just moving from left to right. So this is called forward pass. So we are just passing the changing the weight. We are just finding the activation values by forward passing from input to output layer, and the next one we are going to do is back propagation, because in the first forward pass we won't get the desired output. Take for an example that if you are feeding the image of a dog, and then in the first forward pass you won't get the desired output here, because in case the neural network is properly learned, then it has to say this say this value as 1.0. Because since we kept the label dog as 1, so this and we mapped the 1 to this neuron. So in case if it contains dog, then this neuron has to trigger have the value like nearly just above 0.9. Since that's the maximum probability, at least just let's say, let's for the sake of simplicity, let's keep it like 1.1.0. So in order to get that output, we need to train this neural network multiple times, because in one forward pass we would be having some random values of this weight, so we won't get the desired output. So always it may have some error. So for that we need to do some back propagation to minimize those errors. Let's see how to do the back propagation. So that's it about forward passing in the deep learning neural network, and in our next tutorial we will check how to do the backward propagation in a deep learning neural network. Thank you so much. Cheers.